Hey, what's up, guys? This is Chung here. So today, let's take a look at today's daily challenge problem number 138, copy list with random pointer. So basically, it just asks you to make like a deep copy of a linked list. But the only difference is that for this linked list, other than the value and next pointers, there's also like this kind of random pointers, which means that any node can point to a random node, right? For example, this is the example, right? So there's like a next pointers as the normal linked list, but there's also like this kind of random pointers could be pointing to a different random point node, and our goal is just to make a deep copy. And there are some like edge cases, right? If there's nothing, we just simply return nothing. Yeah. So, I mean, everyone knows how to make a deep pointer, how to make a deep copy, right? Basically, we just make a copy of a new node, and then we just populate the next with a new one. But for this one, since we have a random pointer, right? So let's say when we're making like a node, a copy of 7, right? So we're trying to copy the node of 7, assuming this random pointer is pointing to the last one, to this one. And so once we have populated basically, let's say we populate 7, basically we make a new node of 7, and then we have a next. Of course, we'll make a new node of 13, right? So this is the new node. This is also a new node, and then we just populate the next the new nodes next to to another, like the copy of the node 13, right? And then we also need to make the basically another pointer, another new node to point for a node 1, because the current node's random pointing to 1, right? So which means at the first step, we have deep copied 3 nodes: this one, and this one, right? So it means that when we process when we are at process this 10 here, okay, and when we are trying to make a deep copy of 10 here, right? So the 10 next should be pointing to 1, okay? But so here at this moment, we don't have to make a deep copy of 1 again, because we have already made a copy, right? Deep copy of 1 node when we are trying to make a deep copy of 7, right? So here, when we're at 10 here, so when we populate the new node of 10, the new 10, we should not create another deep copy of 1. Instead, we should just find this deep copy of 1 somehow, right? But how can we find it, right? So at 10 here, we know the next node is 1, right? So from the 1 is original node, we need to find the deep copied version of 1, and then we need to return that, right? And then it leads to like basically what, a hash table or a dictionary, right? Which is the key is the old node, right? And the value is the copied node, right? It's a copied node. So which means that we're gonna have like a hyper functions every time when we're trying to make a deep copy of a node, right? We always check this dictionary. If this dictionary have already has like a copied version of the current node, we simply return that. Otherwise, we make a deep copy and we save it into the dictionary. Yep, I think that's the only thing we need to do here. Cool. So, and other than that, you can either use like the DFS, or the recursive, or a iterative way to loop through the node. So since this one is just like a simple a linked list, we can use the iterative way, which means that so first let's do this. If not had, return none, right? That's the edge case, and then we have a new current. So the current is gonna be the node of the head of the value. None. This is the starting point of the deep copied linked list. Okay, and then similar for the current equals to head, right? And then we have a scene. I'm going to use this scene as a dictionary to store those kind of nodes that which we have already copied at the beginning, right? So the mapping is we have a current equals to the current, sorry, to the new current. Okay, so while current, now we can just do this, right? Now we have a new current, right? A new current dot next equals to what? So I'm going to have like get copied node, right? So current dot next, and then the new current dot random equals to get copy node current dot random. Okay, and then we move forward. We move both the current and the new current forward, right? New current dot new current dot next, and then in the end we just return the scene dot head, right? So yeah, basically we every time when we have like a new a current, right? We just try to make a copy of the current dot next and the current dot random, and so which means that when we implement this get copied node here, we have a node, right? And if not node, right, simply return none else, right? So if node not in scene, okay, we make a copy. Basically the scene dot node equals to the node of node dot value, and then none, right? And then in the end we simply return the scene dot node. That's how we make a copy, right, of the current node. If there's already a one, if there's the node is already exists in the scene here, we simply skip this part. We just return this the node that we have already copied before, right? So yep, I think let's run the code. Accept it. Yeah. So that's it, right? I mean so the only tricky part for this problem is that we have to maintain this kind of mappings between the old node to the new node, so that when we try to get a copy node for the next and for the random. So it could be, I mean, the current next will already have a copy, or the current random already have a copy. So in that case, we don't want to create a new one, because if we create a new one, basically it's two instances of the same node, and we'll be losing the pointers, right? So here we only create when the current node, this node doesn't have a copied version of it, right? And then if it doesn't, we make a copy, and then we store it into the dictionary, and then after that, with the return node here, we'll basically populate the current, the new current dot next and new current dot random, so that we can finish populating the current node, the new current node. And then after that, right, we move the pointer forward for both the current and new current. So by doing this, right, we have the pointer pointing to the same location for the current and the new current. right? This is obvious, right? To be able to move to the new to the next node for the new current, we have to create that node first, right? That's what this get copy node is doing here. So if this one doesn't, if this random node or if this next node doesn't exist, right, we will create that. We'll create that node, and then so that we can move to the next one. Yeah, I don't think I have anything else I want to talk about for this problem. I believe for this problem, there's also like a way that um, I mean, you can skip you. I mean, you can avoid using this dictionary, and but I find it's a little bit tricky to do it. I mean, so that's why I'm not going to uh, cover that solution here. Mm, yeah, I guess I'll just stop here. And yeah, thank you for watching this video, guys. Stay tuned. See you guys soon. Bye bye.